Hey guys, welcome to lesson 5.2 where we continue talking about probability, notations, and rules. So this lesson is going to center around a 2x2 table that has a sample of 600 students. The students are either in-state or out of state, and they're either freshmen, sophomore, juniors, and seniors. So there's 450 in-state students, 150 out-of-state students, so 600 total students broken down into 180 freshmen, 160 sophomores, 140 juniors, and 120 seniors. So the rows are classes and the columns are in-state or out-of-state. Notice each student is exactly a sophomore, freshman, junior, or senior. So these are all mutually exclusive. And the in-state and out-of-state distinction is also mutually exclusive. You're either one or the other. Now, the other thing is in-state and out-of-state are also complementary. So everyone, the total number of in-state students and out-of-state students add up to be the sample size, so 600. Freshmen and sophomore are not complementary because if someone's not a freshman, it does not mean that they're a sophomore. So let's look at a simple event probability of A. So probability of A, if, for example, I want to know the probability that someone is a sophomore, I take 160 sophomores divided by 600, and I get 160 out of 600, or 4 out of 15. The probability that someone's out of state, is 150 out of state students out of 600. So the complement, probability of someone not being out of state, is the probability of in-state, which is 3 out of 4. And the probability that someone is, for example, not a sophomore, I would take all the sophomores, subtract from 600. So probability of not sophomore, I would take 600 minus 160, so 440 out of 600. That's the 600 minus 160 divided by 600. Probability of A and B, things happening both at once. So for example, probability someone is a sophomore and out of state. So I want sophomores that are out of state. So there's 40 sophomores that are out of state. So 40 out of 600. If I want the probability that someone is a junior and in state, so juniors in state, there are 110 out of 600 of those. So A or B, so for example, someone is a sophomore or out of state. It's written like this. The way we calculate that is probability of A plus probability of B minus the probability of both. So I want sophomore or out of state. This would be if anyone is either a sophomore or they're out of state. So the way we do that is we take 160 plus 150 minus the 40 that's in the middle. And the reason we do that is that 40 is common to both, and divide that by 600. So when we do the or, we have to subtract the overlap, subtract the redundancy. Probability of A given B. So if someone is a sophomore given that they're out of state, so I take all the students out of state, and out of those, I find the sophomores. So there's 40 out of 150 of those. Out of state, so order does matter. It says here order matters. I always want to read it this given that. So someone is out of state given that they're a sophomore. So out of all the sophomores, how many are out of state? Out of all the sophomores, out of 160, 40 are out of 40 out of 160 are out of state. So whatever is, figure out what's the numerator, figure out what's the denominator. So reading the table, find the probability that someone is a junior. Just someone is a junior. So junior would be 140 out of 600. I'm looking at the juniors. Probably that they're junior and in-state. So now I'm interested in the intersection, the in-state juniors. So 110 out of 600. What's the probability that someone is a freshman or a junior? Freshman or a junior. So I take all the freshmen, all the juniors, and I get 320 out of 600. It says why is no subtraction needed for this pair? Because there's no overlap. Freshmen and juniors are mutually exclusive, whereas like freshmen and in-state are not. Senior or in-state. So I take all the seniors plus all the in-state students. And now I'm basically interested in someone either being a senior or being in-state. Notice this 95 is being used twice. So I'm going to subtract the 95 and divide by 600. So 120 plus 450 minus 95 divided by 600 would be my probability of senior and out of state. So this would be what? 570 minus 95. So 475 out of 600. Probability that someone is a junior given that they're out of state. Junior given that they're out of state. So out of all the out of state students, how many are juniors? So 30 out of 150. What about out of state given that they're a junior? Out of state, out of all the out of state students, no, this is given that they're a junior. All right, so out of all the juniors, how many are out of state? So why do the answers differ? Because depending on what set we're taking out of, it's gonna have a different denominator. Mutually exclusive, A and B. A and B are mutually exclusive if they cannot occur together. So in the table, the rows are mutually exclusive. No student is both a freshman and a sophomore. So probability of freshman and sophomore is 0. Not mutually exclusive, for example, sophomore and out of state can occur together because someone can be sophomore and out of state. So if there is an intersection between the two, then they are not mutually exclusive. We talked about mutually exclusive. So mutually exclusive, there's no overlap in the Venn diagram. So whereas this would be not mutually exclusive. So if there's an overlap between two things, as there is here between out of state and sophomores, then they are not mutually exclusive. The definition of independence. A and B are independent exactly when probability of A times probability of A and B is probability of A and probability of B. So for example, sophomore and out of state. So probability that someone is a sophomore is 160 out of 600. Probability that someone is out of state is 150 over 600. And is that the same as the probability that they are a sophomore and out of state? So is that the same as 40 over 600? And if we actually do this calculation, we find out that yes, that's true. Therefore, the two things are independent. Now, freshmen and out of state, if we do the same thing with freshmen and out of state, we will find out that the two things are not independent. So knowing that someone's a freshman kind of affects the odds of them being out of state, whereas knowing that someone's a sophomore does not affect the odds of them being out of state. So key term P of A is the probability of event A. Probability of A and B is the intersection of the two. Probability of A or B is add A and B, subtract so probability of A and B is probability of A plus probability of B minus the probability of A and B. You want to subtract that redundancy. This means A given B. Complement is just everything that's not in set A. Mutually exclusive means that their overlap is 0. They have no elements in common. Independent means that probability of A times probability of B is probability of A and B. And dependent means they are not independent. So summary, one table answers everything. Probability of A from the margins, A and B from one cell, A or B by adding and subtracting the overlap, A and B by restricting the denominator. Order matters, so probability of A given B very frequently is not going to be the same as probability of B given A. Mutually exclusive means probability of A and B is 0. And independence is a test, not an assumption. Sophomore and out of state pass the test. This definition, and freshmen and out of state fail. They are dependent. So that is lesson 5.2.